That's why we should never pour water into our coolant tank. So this is our water pump, and this is the outer cylinder walls. This is where the coolant would flow through.
Would you look at this?
Yeah, well...
Would you look at that?
Yeah, there's a few more blemishes on the car.
Oh my gosh, just look at it.
The car is not perfect.
Just look at it.
Let me explain what I showed you in a bit more detail. So we're going to show the coolant flow journey. So we pour coolant into our radiator. It's going to make it up. This is our water pump. Then this is going to fill the cylinder cooling jacket. So you've coolant going all around the outer cylinders to keep it cool. And this is where we're seeing a lot of rust water and contamination, as well as the water pump. So using tap water instead of proper coolant in a car's coolant system causes so many problems like rust and corrosion. So tap water has minerals in it. The minerals rust the inside of the engine, radiator, water pump and heater core. Rust flakes can clog up passages and reduce cooling. Overheating, coolant has special additives that help it absorb heat better and prevent boiling. Plain water boils sooner, especially in hot weather, which can lead to overheating. Freezing damage, so water freezes at 0 degrees Celsius, so coolant lowers that freezing point by a lot. If water freezes in the engine during winter, it can crack the engine block or radiator. Limescale buildup, water, tap water leaves behind limescale, like what you see in like your kettle or shower head. The buildup reduces flow inside the coolant system and makes the coolant less effective. It also shortens the lifespan of parts like the water pump, thermostat and radiator will wear out faster when coolant isn't used because they rely on the coolant's lubrication and anti-corrosive additives. So let's start from the top and get this sorted. So we're gonna do the timing belt, camshaft seals and water pump and flush all that bad stuff out of it in this video. So here we're looking at the front of the engine. We can see that's the crank bolt, which is going to be the toughest bolt to remove. I think it's 350 Newton meters. We have two auxiliary belts running our power steering and running our alternator. So we can see there we need to loosen the tensioner bracket on the alternator. So that will give us a bit of slack to pop off these belts. Our clutch fan was attached to our water pump pulley, which we removed in the last video. So once we get those belts and pulleys off, we can remove the timing belt covers, which will reveal the timing belt then. Okay, so now we've removed the water pump pulley, which was just 4 bolts on the front. We're unbolting the timing belt cover here. There was a bolt here as well for it. This is our water pump that you can see here, which we just removed the pulley from. So this bracket here is the tensioner for our alternator that we just pulled off. This is a look at the front of the engine now with the timing covers off. So you'll have timing marks on the cam sprocket up here. It's going to be hard to see, but there's a little arrow there going to a line there that's notched into the block. Trying to focus on it, and here we go. I don't know if you can see that, but I'll circle it so you can get a better picture of it. And there should be marks for the crankshaft then as well that you can see here. I'll circle it as well just to make it more obvious, but you want to rotate the engine to top dead center on cylinder 1 before trying to remove the timing belt. Okay, so we removed the timing belt tensioner and cam sprocket, and if you're wondering why my engine is covered in oil at the front, it's because this camshaft seal is leaking, so we're going to be replacing that as well with a brand new one. So here's our new camshaft seal. It's another view of it. This is the old camshaft seal removed, so this is us going to be putting the new one on. Now all we have to do is torque it to a safe spec. Should be easy, should be straightforward. What could go wrong, right? I turned an hour job into an all-night job. So here's the snap bolt in the cylinder head.
How, in the name of all that's holy, did you do that?
Yeah, so this is the snap bolt, just over torqued it, so we're going to have to try get it out and we'll get a new bolt to go into it. It's going to be a long night. So what I'm going to try to do is now drill it out, leave the head on the block, leave the block in the car. Don't want to be taking that out. Let's hope we can get it out without damaging threads. So we got it out, new bolt in, torque to spec. So now let's get back to putting the timing chain back together. This is the timing belt tensioner pin. It's looking very worn, but it does clean up very well. However, we still just bought a new one anyway. So we have our new belt on. We're just making sure the timing marks line up before we set the tension on it. It's all looking fairly in order. So I just make sure there's good tension on the belt now. We have our new spring tensioner in that you can see here, and we have our new water pump installed now as well, and our camshaft seal. So we're starting to put it back together now. So now we want to get everything cleaned up and painted. So this is the coat 1 for the cam cover being painted, and this is it back on the car. So we've got new auxiliary belts as well. Everything is painted, torque to spec, good tension. Just need to clean up the alternator and power steering pump. We need to torque the crank bolt to 350 Newton meters. Here's a look at it from the front of the engine, all finished, except we're not actually finished. So if we go back here for a second, we have set the timing for the crankshaft and the camshaft so that the valves will not ram into the pistons, but we did not set the ignition timing. And what I thought was a gear that runs the fuel pump is actually a gear that runs the fuel pump, but also behind that it runs a worm gear that runs the distributor, so that controls spark timing. So with that not aligned as well, means we're going to be out of timing, which means the engine won't run or will run very rough. Let's explain the timing here. This is our camshaft gear, okay? This is our crankshaft gear. Our camshaft has to be in time with our crankshaft, otherwise pistons mash into the valves. This is our water pump. This is our tensioner pulley. This puts tension on the actual timing belt to make sure it doesn't jump. This gear here runs our mechanical fuel pump, which I thought that's all it did, which means it doesn't matter what degree that gear is at in relation to the camshaft or the crankshaft. But it's actually also running our distributor, which controls our spark timing, which means if this gear is out of whack, then it's going to spark at the wrong time and the engine is either not going to run or it's going to run really rough. Let's just explain the distributor's job and where the spark comes from. Your battery only produces 12 volts, which isn't enough for a spark plug. So your ignition coil is a high voltage transformer that steps up the volts from 12 volts to tens of thousands of volts. Then that sends it to your distributor's pin, that rotates around and then delivers spark each time it rotates to each different spark plug. Here's a look of the distributor cap off, so we need to unbolt this, move it, and now we can see we have it lined up, so now our ignition is in time as well. Took the valve cover off, then cleaned it up, hit it with some high temp paint. I'm going to show you in the next clip the top end ticking, so we need to set the valve adjustment as well. So on most modern engines you wouldn't have to set the valve adjustment. A lot of engines use hydraulic lifters and they use engine oil pressure to automatically maintain a zero valve clearance. Then a lot of JDM engines like Toyota, Honda, some European double overhead cam engines use shims, so a thin metal shim that sets the valve clearance, but to adjust them you have to swap out the shims for a thicker or thinner one, and this would involve removing the camshafts, which is a bit of a pain. So the M20 engine we're working on here uses eccentric adjusters, so each rocker arm has a small eccentric, an off-center disc with a small screw, and rotating the eccentric moves the rocker slightly, increasing or decreasing the valve clearance, and then you lock the eccentric with the nut once the gap is correct. So the gap that needs to be set for this engine is 0.25 millimeters. So the nice thing about this is they are super easy to adjust. There's no need to buy shims. You can be done at home with some basic tools. All we need is a feeler gauge. These need to be adjusted every 10 to 15,000 kilometers or they get noisy. Another thing we noticed with the rocker cover off on this engine is it could have done with more oil changes throughout its life. So couple of things we're doing to fix that. So we have an oil spray bar, that's what's going across the top here, and that's supposed to spray oil onto the cam lobes and rockers, keeping them well lubricated. And if you don't replace your oil at short intervals, the oil becomes to get thick and a bit sludgy, and it's not going to spray through those oil bars, so you're not going to get the proper lubrication on the head. So we've cleaned all that out. You can see that the oil is spraying now nicely, and the tick has also gone out of the top end. So this is the rocker cover back on then, with a new gasket all painted up and looking well. Here's a quick video of it. So with the rocker cover, we have the timing belt covers. You can see the water pump is on. That's before the pulleys were on. Just to show you how little room we had with the new thicker radiator in. So yeah, I mean, the stock fan was never going to go back on, and we were never going to be able to put a pull fan on it, so we needed to put it on the other side of the radiator to push air. Okay, so that's all for this video. Stay tuned for part 4. Please like, comment, subscribe if you enjoyed it. Stay tuned.